Okay, section 5.4 is called solving special systems of linear equations, and what makes these special is that there are three different kinds of solutions of systems of linear equations. Okay, we can have one solution, which is what we've been working on the most. Okay, when the lines intersect, we have one solution, and that's the point of intersection. Okay, but there's also something called no solution. When the lines are parallel, and remember, when lines are parallel, they have the same slope. Okay, these lines are never going to intersect. No matter how far or how much you graph them, they're never going to intersect. Okay, so they would have no solution because there is not a point in which they intersect. Infinitely many solutions, there really is two lines here. Okay, so if the lines are the same, which is what it says right there, if the lines are the same, there's going to be infinitely many solutions because they cross paths at infinitely many points. So this first example, there are two different methods in which you could do this. The first is graphing, and the second is substitution. I'm going to start with graphing first. Okay, you need to remember how to graph a line from chapter 4. Okay, so I start with a y-intercept of 1. My slope is 3 over 1, so I rise 3 and run 1. Rise 3 and run 1. Connect my points. Okay, 3x minus 3 is y-intercept at negative 3. I rise 3, run 1. Rise 3, run 1. Rise 3, and run 1. As you can see, these lines have the same slope, okay, which also means that they're never going to intersect, so this would be no solution. Okay, the other method you could use is substitution. Okay, in substitution, you know, you have the, I'm going to erase this. Okay, you can substitute in 3x plus 1 for y. So you would have 3x plus 1 equals 3x minus 3. Well, when you subtract 3x from both sides, those both go away and you're left with 1 equals negative 3. Okay, but 1 doesn't equal negative 3, so right away you would know that this is no solution as well. Some methods are going to be easier than others to either do substitution, elimination, or graphing. You also could have done elimination on this one. All right, you have some on your own examples. I encourage you to pause this video at some point and try some of these examples on your own, but I will go in detail through all three of them. This first one, whenever I see y equals and y equals, keep in mind you can pick any method, but whenever I see y equals and y equals, I always want to do substitution. So I have negative x plus 3 equals negative x plus 5. Okay, if I add x to both sides, these both disappear, and I'm left with 3 is equal to 5. And I know that 3 is not equal to 5, so this would be no solution. The second one, I am going to rewrite this second equation in y equals form. So I'm going to subtract 5x from both sides and get y equals negative 5x plus 0. Okay, I want you to start to realize that, hey, these two problems have the same slope, and you know that problems have the same slope are going to have no solution. Okay, so if I were to graph these, they both have the same slope and different y-intercepts, so they never intersect. I could also do substitution and have negative 5x plus 0 equals negative 5x minus 2. If I added 5x to both sides, I would have 0 equals negative 2, and I know that that never can be true, so this would be no solution. And number 3, I'm going to choose to do elimination on this one, but before you can do that, you need to rewrite this first equation so that it's an x plus y equals a number form, okay? Which means I need to subtract 2y from both sides. So if I were to rewrite this, I would have x minus 2y equals 10. Okay, and then I need to multiply. I'm going to choose to multiply the first equation by a negative 2. I'm going to choose to eliminate the x's. And when I do that, oops, I knew something wasn't right. I'm going to multiply the first equation by negative 2. I'm going to rewrite the second one so we don't get confused. So this is my actual system. Okay, and I'm actually multiplying this first equation by negative 2. So I have negative 2x plus 4y equals negative 20, and 2x plus 3y equals negative 1. I didn't change that equation, so all I'm doing is rewriting it. Okay, I eliminated the x's, and when I add these two equations together, I get 7y equals negative 21. Divide both sides by 7, and I get y is equal to negative 3. Now I need an x-coordinate. This one looks like it's going to have a solution. Okay, so to get an x-coordinate, you pick an equation. I'm going to pick this first one. Okay, and I have x is equal to 2y plus 10. Okay, and I know that y, I solved for down here, is negative 3, so 2 times negative 3 plus 10 gives me negative 6 plus 10, which is 4. So my solution to this problem is 4, negative 3. So I would go ahead and write that this problem has one solution. All right, for example 2, this will be an example of a problem that has infinitely many solutions. And if you remember, these are the ones where the two lines are exactly the same when you graph them, which means they intersect at infinitely many points. Okay, so it says the perimeter of the rectangle is 36 units. Okay, but you got to keep in mind that this is 2x and this is 4y. So if I was writing an equation for this, it would be 2x plus 2x plus 4y plus 4y is equal to 36, which is really 4x plus 8y equal to 36. Same thing down here, it would be 6x plus 24y is equal to 108 units. Okay, so this is 12x plus 24y is equal to 108. So my system is 4x plus 8y equals 36, and 12x plus 24y is equal to 108. Okay, so now I need to determine, I know I don't have any matching coefficients, and I know one of them has to end up being negative, so I have to figure out which one I need to multiply by. I'm going to choose to get rid of the x's, so I need to multiply this by negative 3 so that this turns into negative 12. Okay, so this is now negative 12x plus negative 3 times 8y is actually going to be minus 24y equals 36 times negative 3, which is negative 108. Okay, my second system, I didn't change it, so it's still 12x plus 24y is equal to 108. Okay, as you will notice, if you add these two equations together, this cancels out, and this cancels out, which means you're left with 0 equals 0. Anytime you have 0 equals 0, it is infinitely many solutions. All right, these last three on your own problems, you need to solve the system of linear equations. You can pick either substitution or elimination. Sometimes some are easier than others. On this first one, I notice I have a plus y and a minus y, which I know is going to eliminate. So I'm going to add x plus x and get 2x, and add 3 plus a negative 3 and get 0. When I divide both sides by 2, I get x is equal to 0. Then I need to plug that back in to find y, so x plus y is equal to 3. 0 plus y is equal to 3, and my y is equal to 3. So my solution is 0, 3. So this one I would have one solution. This second problem I think is also easiest to solve with elimination. So I'm looking at my y and 2y. You could also eliminate the x's. It doesn't matter either way. But I know that one of these needs to be negative. So I'm going to multiply this first equation by negative 2. So that gives me negative 4x minus 2y equals a negative 10. My 4x's eliminate. My 2y's also eliminate. Alright, that doesn't happen all the time, and I'm left with 0 equals negative 10. And you got to ask yourself, does 0 equal negative 10? And no, it does not. So this would be no solution. And lastly, number 6. I think this one is easiest to solve using elimination as well. Okay, so you need to multiply this first equation. I already have a positive value and a negative value. I just need to multiply this top equation by 6, which gives me 12x minus 24y is equal to 6 times 10, which is 60. So my 12's eliminate, my 24's eliminate. I'm left with 0 equals 60 plus, or excuse me, negative 60 plus 60, which is also 0. Remember, when 0 equals 0, you know there is infinitely many solutions. And that's it. See you tomorrow.